A very good morning to one and all. A very good morning. Myself J. Anusha, working as lecturer in physics at SS Government Polytechnic, Zahirabad. I'm working in general section and I'm working under Department of Technical Education, Telangana. And the subject I'm dealing with is applied physics, that is for first year, second sem students. The subject code is 18 common 103F. And the topic what we were discussing in previous sessions also, that is electricity and measuring instruments, that is fifth chapter from our syllabus. Now in today's session, or on completion of this class, we are going to learn about Wheatstone bridge. And to understand this, we are taking help of a small PowerPoint presentation. The main objective of our classes, on completion of this period, you would be able to understand what is Wheatstone bridge, and we are going to derive what is balancing condition for Wheatstone bridge. Now let us recall what we learned in the previous session. We have learned about Kirchhoff's first and second laws, and also we have seen what is the importance of Kirchhoff laws. What are Kirchhoff's first and second laws? They are also known as Kirchhoff junction law, Kirchhoff loop law, or simply Kirchhoff current law and Kirchhoff voltage law. You can remember these two statements very easily, that according to first law, the algebraic sum of currents meeting at a junction is equal to 0, and according to second law, the algebraic sum of potential differences meeting at a the potential differences in a closed loop is equal to 0, where potential difference is nothing but simply it is product of current and resistance. That is according to Ohm's law, V equals to I into R. Now let us see Wheatstone bridge. So this is one of the most accurate methods of measuring resistance. So simply, it is not any bridge, it is an electric circuit which is designed like a bridge. You can see here it is designed by Wheatstone. According to him, four resistances PQRS, or four resistors PQRS, are connected such a way that they form a closed circuit ABCD. Now, in this closed circuit, B and D junctions are connected through a galvanometer, and for this galvanometer resistance is G, small g, and other two junctions A and C are connected with a battery of EMF E, which is indicated by capital E. Now you can see here a very important diagram. If you understand this diagram carefully, it is very easy to derive balancing condition of Wheatstone bridge. See, A, B, C, D and A, it is like a closed circuit. B and D are connected through galvanometer. A and C are connected through battery EMF. So this is at A and C, and galvanometer which is at B and D. Now there are four resistors PQRS. Now when we switch on the battery, the current is flowing from battery towards junction A. Now when it reaches the junction A, up to junction A, there is only one path for I. reaches to junction A, there are two paths for I to move. So this I is divided as two currents, I1 and I2. This I1 is passing through the resistor P and I2 is passing through the resistor R. Now when I1 reaches the junction B, again there are two paths for it. So I1 is divided into I3 and IG. Now this IG is passing through the galvanometer and it is reaching to D, and I2, which is passing through the resistor R, is reaching to D. Now these two are formed as the fourth current I4. Now I3 and I4, which are passing through the resistors Q and S, they are meeting at junction C and they are forming as current I, which is again passing towards, or which is moving towards the EMF. So that is about Wheatstone bridge. Now this is what we have seen. Now applying Kirchhoff's current law at junction B. Now in the picture you can see at junction B there are three currents, I1, IG and I3, where I1 is flowing towards junction B and I3 and IG are flowing away from the junction. So according to Kirchhoff's first law, there is a sign convention for currents which are flowing towards the junction are taken as positive, and the currents which are flowing away from the junction are taken as negative. So by using that sign convention, at junction B, we got an equation as I1 minus IG minus I3 is equals to 0. Now similarly for the junction D, at the junction D you can see I2, IG and I4, where I2 and IG are flowing towards D and I4 is flowing away from D. So what is the expression here? That is I2 plus IG minus I4 is equals to 0. So we'll take it as equation 2. Now we are using, okay, first let us see about voltage and then we'll apply this balancing condition. Now Kirchhoff voltage law, which is also known as Kirchhoff's second law. So we are using that for loop ABDA, in which you can see I1 into P as one potential difference, IG into G as one potential difference, and I2 into R as one potential difference. Now what is loop direction? That is from A to B, B to D and D to A. Now when you are going to consider the currents, if the currents are also in the direction of loop, then the potential difference is taken as positive, and if the current is not in the direction of loop, then the potential differences are taken as negative. Now by using this sign convention, we got an equation as I1 into P plus IG into G minus I2 into R is equals to 0. That is at the loop ABDA. And at the loop BCDB, I3Q minus I4S minus IGG is equals to 0. Now, if current through galvanometer is 0, that is if IG is equals to 0, so as we have equation 1 and 2, if we substitute IG 0 in those equations, we got I1 equal to I3 and I2 equals to I4. Take them as equation 3 and 4. And similarly substitute IG 0 in the voltage equations, that is I1P is equals to I2R and I3Q is equals to I4. Yes, we are considering them as 5th and 6th equations. Why we consider Ig as 0? Because at this condition the bridge is balanced. So we can say that the balancing condition, or the balancing to be the bridge to be balanced, the condition is Ig should be is equal to 0. Now we got equation 3 and 4. Now if we divide 5 and 6, dividing equations is nothing but divide both the left hand sides and both the right hand sides. We got I1P divided by I3Q is equals to I2R divided by I4. Yes. Now as we have 3 and 4 equation, that is third and fourth equation, I1 equals to I3 and I2 equals to I4. In the place of I3 we can substitute I1, and in the place of I4 we can substitute I2. Now substituting, and we can cancel both I1s in numerator and denominator and both I2s in numerator and denominator on right hand side and left hand side. So what is remaining? P by Q is equals to R by S. This is known as balancing condition of Wheatstone bridge. We got relation between the four resistances which are present in this circuit known as Wheatstone bridge. So what is application? Two resistance are known, other two can be compared. If three resistances are known, we can find what is the unknown resistance. This principle is used in meter bridge and also in potentiometer. Now we'll see how we can use this principle in meter bridge. So what is the use of Wheatstone bridge? By using this we can find the relation between resistances. If two are known, other two can be compared, and if three are known we can find the unknown resistance, and practically we can use this principle in meter bridge. Now let us summarize what we learned in this session. We learned about Wheatstone bridge network, where it is designed like a closed circuit with which is connected, or I should say the circuit consists 4 resistors with the resistance values PQ and RS. So balancing condition is P by Q is equals to R by S. Now let us solve few problems. In Wheatstone bridge network, the value of P is 3 ohm, the value of Q is 4 ohm, and the value of R is 6 ohm. And one unknown resistance S is connected, and now the bridge is balanced. Find the value of resistance S. Now using Wheatstone bridge principle, P by Q equals to R by S. So substitute values. 3 by 4 is equals to 6 by S. Cross multiply, will get 24 by 3. So S is equals to 8 ohm. When Wheatstone bridge is balanced, current through galvanometer is 1, 0 or greater than 1 and none. It is 0. Very important condition or very important point to remember is to be or to balance the Wheatstone, the condition should be current through galvanometer should be equal to 0. When Wheatstone bridge is balanced, the resistances in arms on one side of the galvanometer should be of same order, different order, none. They should be in same order. The Wheatstone bridge is most sensitive when arms ratio is equal to 1, greater than 1, less than 1. That is more sensitive when their ratio is equal to 1. Now condition of Wheatstone bridge is PQ equals to RS, P plus Q equals to R plus S, P by Q equals to R by S, or P by S is equals to Q by R. It is P by Q is equals to R by S. Now here are some frequently asked questions from this topic. Describe Wheatstone bridge. So you need to draw the diagram and you need to explain this Wheatstone bridge, and then to derive condition for balance of Wheatstone bridge. To derive, will use Kirchhoff first law and second law. To use Kirchhoff first law, we need junctions, and to use Kirchhoff's voltage law, we know we need closed loops. So with this, we are concluding our session. Thank you so much. I hope this class is helpful for you. Once again, thank you so much.